And finally, for question three, question three for the last page, you were given three systems of equations, and you needed to solve each system in a different way. Make sure you use all three. Show your work and record your answers, and in a coordinate pair x comma y. This is something that many of you did not do, and I didn't really detect a lot of points for it, but I want you to make sure once you've got an answer, write it as an ordered pair. It's the x value comma the y value. Because remember, we're finding points on the Cartesian coordinate plane where these lines intersect from each other. So the question is, the first choice here is equal values method. Well, it turns out that I think C is probably the best candidate for this. The reason why is if you look at it, it says, hey, x is something, and then x is this thing right here. So clearly x is equal to itself, and because of that, we can just go ahead and plug into it. So that's the equals value method in a nutshell, right? We start out with the statement like, hey, and I'll write it over here so that you can see this. All right, hey, x is equal to negative 7y plus 11, and we're told that x is equal to 3y minus 9. Well, the idea is that x is clearly equal to itself. Those are equal values. And you can see from the first equation, this is one way that you can write x. And from the second equation, we can see this is another way that you can write x. So what we do is we just take and plug those in. So I'll write the negative 7y plus 11. That's the first way from the first equation that we can write x. And then the other way that we can write it is 3y minus 9. That's the second way. So this equal value method starts with that, right? X is equal to itself, and then here's negative 7y plus 11 is equal to 3y minus 9. If I go ahead and, there's a lot of different things I could do, but if I go ahead and, for example, add 7y to each side, this would become 11 equals 10y minus 9. And then I might add 9 to each side, giving me that 20 is still 10y. And then if I divide both sides by 10, we get that 2 is what y is. So we've got part of our answer. We know y is 2. And now it doesn't matter really which equation I pick. I could use either one. I'll just use the second one here. And it says, hey, take 3 and multiply by y. And you can see I'm just grabbing 2 is what y is, and I'm just placing it right there. So that's 3 times y, and then it says minus 9. Minus 9. Again, 3y minus 9 is what x is. 3 times 2 is 6. 6 minus 9 is negative 3. So my x value is negative 3. Now, writing this as an ordered pair, I would write it as negative 3 comma 2. That's the x and then the y value. That's the location where these two equations would meet each other. And by the way, this was choice C, so I'm going to write C here because I did problem C using the equal values method. The next technique that was listed was substitution, and I definitely like B for that because you can see that one of my variables, x, is isolated in terms of y, right? So this thing that I've highlighted in blue is a perfect substitution for x. So our strategy is to replace the x in the first equation with something that's equivalent to it from the second equation. The thing that's equivalent to it is negative 6y minus 20. So let's scroll down here and look at this. I've already pasted the actual equation here. So when I do that, right, I'm going to be rewriting the top equation. Again, this is equivalent to x, so I'm just going to rewrite this top equation as negative 2 times the quantity of negative 6y minus 20. Now, all that I've written so far is minus 2x, right? Everything that you just see I wrote was minus 2x. That's negative 2 times x, and then plus 3y, and that equals negative 5. So again, the thing that I've highlighted here is the same thing as x. So we're looking at negative 2x plus 3y equals 5. Now, if I use the distributive property on the left-hand side, this becomes negative 2 times 6 is positive 12y, and then plus 40 and then plus a 3y, and that should equal a negative 5. So 12y plus 40 plus 3y equals negative 5. I'll combine these two. This is 15y plus 40 is negative 5. And then I'm going to subtract 40 from each side. So that gives me that 15y is negative 45. And if I divide both sides by 15, I get that y has to be negative 3. So part of our answer is y is negative 3. And I'm going to go ahead and use the second equation here to figure out what x is. Again, this equation tells me that x will be negative 6 times y. We just discovered that that's negative 3, and then minus the number 20. Negative 6 times negative 3 is positive 18, so I've got 18 minus 20 is what x is, and 18 minus 20 is negative 2. So x is negative 2 and y is 3, negative 3 rather. And if I write that answer as an ordered pair, it would look like negative 2 for x and negative 3 for y. And this is equation or system of equations from B. So we've used C and we've used B. That means this elimination method is going to have to be A. So let's go ahead and copy that equation down. So the general idea for elimination is to get it so that your coefficients for either x or y are opposites of each other. And if you do that, then when you combine the equations, right, equal things plus equal things yields equal things, one of the variables will eliminate. It'll cancel out. Probably I shouldn't say cancel out. It'll eliminate, right? Something plus something is 0. And I'm going to, actually, several of you had good ideas on, there's no reason why you couldn't multiply the second equation through by negative 4. The way that I did it was I multiplied through by a positive 3, this second equation. And the reason why is I end up getting a positive 9y and a negative 9y in the second equation. So let's rewrite this equation, the second one. If I push a factor of 3 across all the terms, I get 3x minus 9y equals, 3 times 29 is the number 87. And let's just rewrite the top equation again. Here it is. It's 4x plus 9y, and that equals 11. And again, you can see right here, right, there's a positive 9y and a negative 9y. When we combine those are exact opposites of each other, so they're going to be gone. So I end up getting on the left-hand side 4 plus 3 is 7 x's, and on the other side 11 plus 87. 11 plus 87 is the number 98. And then to solve for x, x equals 98 divided by 7. Let me check that arithmetic. Yeah, I have very, very good authority that that's the number 14. And now that I know that x is 14, I need to set out to figure out what y is. And it doesn't matter which equation I use. I'll use the second or the top equation. So I'm just going to plug in this value of x. So I've got 4 times x. Again, we just found x to be the number 14, so I'm placing it there. Plus 9y equals 11. 4 times 14 is 56. Plus 9y is 11. Now to subtract 56 from both sides, 11 minus 56 is negative 45. Is it? 11 minus 56.
That makes minus 45.
Yeah, that's what I thought. And then if I divide both sides of that by 9, I do get that y is negative 5. So y is negative 5 and x was 14. So my solution as an ordered pair would look like, again, the x value first, comma, the y value. So 14, comma, negative 5. That concludes the solution videos for the Chapter 6 study team test.